Hello. This is Postgres FM. My name is Nik, Postgres AI, and as usual, my co-host is Michael of PG Mustard. Hi, Michael.
Hi, Nik.
And we have a great guest today, Dmitry, who is a very experienced DBA, originally Oracle, now Postgres, already many years. Hi, Dmitry.
Hi. Thanks for inviting.
Thank you for coming. So we have, I think, for me, it was surprise when you did it, when you built this tool. And I didn't expect that it's coming to Postgres ecosystem. But obviously it's something new and in the area which is in my personal key interests lately. So active session history analysis, wait event analysis. But you did it very differently compared to what we usually did with PG wait sampling or other tools, performance insights and RDS. So it's a great tool. Where to start?
Yeah, so I think we can start with the time when I first started working with Postgres. I start switching from Oracle. When Oracle, one of my favorite topics always and the tasks was performance-related investigations. And when I switched to Postgres, of course, I start looking for similar tasks and understood that the way of Postgres troubleshooting is very different from how it's done in Oracle. And definitely they felt lack of tooling, lack of a standard approach, and so on. Okay, so after some time, I realized that there are some tools that can bring similar feeling, let's say, what I had in Oracle. And I'm talking about the wait event analysis because in Oracle world, it's a given thing.
Yeah. I'm going to interrupt. So when did this switch happen from Oracle to Postgres for you?
Recently, I checked this. It happened 10 years ago.
2016, roughly. I remember very well a big stream of big wave of people coming from Oracle in 2013, 14, and all of them were complaining about lack of wait event analysis. This is how two columns were added to PGSet activity. It was maybe a couple of years before basically your switch. And you also had this same feeling like these tools are needed.
Yeah. Because when you work with Oracle since, 2002 or something like that, it's a given way of troubleshooting. Any Oracle guideline, any book, any training, official, non-official, says to just open the active session history. And so it's a gate that you go through and you start with. And so I tried to use the same approach with Postgres because for me, it was so obvious why it's a way to analyze the performance, because basically what's the wait event say you. So why it was slow, where the session spent the time, session or database in general. So you do not need to guess, was it IO or CPU, basically where it spent time. So it just says very clearly. So then why it happened that way? So you need to investigate, but at least you know where, because the regular approach in Postgres just can say that this query was slow. In average or with some hacking, you can get some precise numbers of the execution, but it does not give the idea why it was slow. Okay, yes, you can use the explain analyze to see where in the plan you spend the time, but again, it does not explain why. Sometimes this join takes, 1 second, and sometimes 10 seconds. From the plan perspective, it looks the same. And the tooling for wait event analysis evolved year by year. And so we have the PG wait sampling. And since they introduced the null event tracing as well, so it became really tool that give really good data, good source for wait sampling analysis. And I use it everywhere where I manage Postgres, and if it's self-hosted Postgres, for sure I will convince the owner of this Postgres to install PG wait sampling. It's a default way of analyzing. On all my dashboards, it's the first panel you see when you open any dashboard that I created. So it's a wait event analysis. I convince all my colleagues to use this approach.
You convinced me to put this ash graph on the top of the first dashboard, which I resisted initially because the first dashboard for me was seen as very shallow and very wide troubleshooting where you identify the areas. But you convinced me to put ash graph on the very top, and now I'm convinced. Yeah, it's a great idea. So it very quickly helps you understand some pain points for performance.
Yeah, I will try to make it brief. Two examples when it's the wait event analysis shines. So one was there was a migration, hardware migration from let's call it this old hardware to new hardware. The data files stored in the storage appliance, so we just remounted. So the data layout was the same, everything was the same in terms of the data layer, storage layer, but the hardware, the compute part changed and changed to the highest spec. So the number of virtual cores increased, the clock increased, everything increased. All tests were good. When we start loading production, so we see the really huge degradation in performance. And so what you would think, so the plan flip or something like that, but you have the same, absolutely everything is the same, just hardware is different. So it basically cannot be planned because the parameters are the same. So
your slide deck has very interesting example, very simple, so anyone can understand about contractors doing some work. So in this very example you describe right now, it's like basically you hired a different team and do the same work, but it does it very differently, right?
yeah.
So that
And it's
example, I just to explain what like those who haven't seen. So it's a simple like there are contractors. They say we were busy, we spent so much time, and without wait event analysis, you just know they were busy. But what they exactly were busy with, you don't know. And in this case, okay, they were busy with I/O or something else, right? And
yeah, exactly. So,
switching hardware, you see different picture and so what was in the end of that story?
so it was problem was LV lock manager. So you know it's one of your favorite LV locks.
Very
Yes.
well. A lot of dots are connected here because we spoke about so many problems which are explored with wait event analysis on this very podcast. So, right, Michael, you remember Lock Manager, Lightweight
Yeah,
Locks?
of course. It feels like whenever there's like a system-wide issue, it's such a great starting point, right?
That's sorry.
And that's the reason next case when I will say that's
Let me
on lower
first
level.
disagree with Michael because I agree on one side, yeah, system wide, but on the other side, more and more I think we just don't have this tool yet, but it should exist on PG Master. We should have it. I mean, we have plan analysis, and for one call, it would be great to see wait event profile as well. Because
Okay, yeah. So
imagine we were holding like we were blocked
yeah.
by lock acquisition which were pending. You will see a lot of time spent, buffer numbers are low, and that's it. You need to guess. With wait event analysis for a single query execution, you will see, okay, this was lock wait event type.
But wait, but I think this is where we get into the core of what Dmitry's done, which is cool, which is moving from sampling to tracing. I think historically
Yes
we've
and
been
no
reliant
again.
on. Pardon?
Yes.
I do think it's really important. Maybe I'm wrong, but my understanding
I also
is with
thought
sampling,
this is what expectation I had as well. It's about a single backend tracing. But let's move on and hear what Dmitry will say. It's not exactly.
Yeah, just the next case when the wait event really saved a lot of time. And when this single backend analysis, I mean, it's single backend analysis case, it does not work only on the instance level. It's on the single backend, it also works. Had a case. I got the complaint that sometimes query takes from few milliseconds and it's killed with 1 second timeout. We have, I don't know, 100 calls, 10 of them failed with 1 second timeout. And the query is primary key lookup. So they cannot mess up with the plan for this case. So it's just a B3, primary key lookup, very simple. It's not join, nothing. It's just very simple lookup.
And it's not lock manager contention because exactly lock manager contention in many cases it's primary key lookup. It was not that.
Yeah.
Right? Okay.
So you open the dashboard, so you don't see any spikes of any specific wait events. So it's definitely very low level with some specific backend problem. So I also captured just in case the explain and analyze. The plan was the same, so everything was the same. But sometimes it goes from few milliseconds to 1 second, and I start sampling. So I make some custom scripts that will just catch the needed backend and start sampling. And I saw that when it's slow on I/O. I mean, I saw the I/O, but look how it can be just a very simple read. So it just reads very few blocks from disk. So next step, so I understood with the wait event analysis, it's nothing else but just slow I/O for some cases. And with the eBPF and tracing these backends, I understood that's the problem with the long tail latency on the storage appliance that we use. Sometimes it goes from 1 millisecond to tens milliseconds. And indeed, if you're not lucky enough and you need to read these blocks from disk, not from memory, not from OS cache, these even few blocks become seconds. And and I think without wait event analysis, it will be just guess game. But
Well,
this just in a couple of days, I found the problem.
couple of quick questions. One
Yeah.
is around I like you can get IO timings in explain analyze output. Obviously, it's a bit tricky if they're always getting cancelled. I don't know how you got the explain analyze for the queries that were timing out. Actually, how did you do that?
I just increased the timeout for some
Okay.
portion of them
Yeah.
to make this finish in few seconds. Yes.
And did you
DBA
have
should
IO
have statement
timings on?
amount 0, right? It's DBA.
Yeah.
Did you have IO timings on the server?
Yes, I do. But when you have 1K calls a minute of this type and just very few fails, you cannot track it. It just so it's one of my favorite topics that averages. It's every time. So you have
Yeah.
to have to have P99 and better more nines to see the actual picture of the
Or
senior
yeah.
system.
Just to push back, I think this is a really interesting topic. I think actually in this one specific case, auto-explain might have been okay. Like that's where it can be really good in terms of catching the outlier queries that go beyond a certain thing. As long as you've got the IO timings on. In this one case, we might have seen, IO timings are the issue for these slow queries. But I'm sure there are other examples where the wait events would have shown something more interesting.
But wait event will analysis, or not auto-explain, will show you the plan, will show you timing if you enable it, will show you buffer numbers if you enable it. Good. But it won't show you wait event profile. Although now I think, why not? It's a good idea probably. This is maybe, even maybe better than for manual explain to have it in auto-explain.
I think you're right, but I think I was talking about track IO timing. You know the parameter track IO timing?
Yeah, IO timing, great. But IO timing is working, first of all, it's working at higher level. But what if it would be not IO,
Yeah.
but IPC or lightweight local or lock or something like full picture would be great to have, right? Also, wait event, like this is a wait event type level. We have how many, like 7, 9 wait event types, but how many wait events? Hundreds. So it's very precise understanding what system was doing. So I think, just imagine for auto-explain to have a wait event profile logged optionally. I think it's a good idea for those who want to hack Postgres right now.
Yeah, me too. And I think it probably transitions on to like, why don't we have this? What are the downsides? What's the overhead? What are the like tricky parts of this?
Yeah.
And we will go there. Yeah, because it's definitely a thing that I cannot take out of my mind for weeks already. And so this last case with this single backend problem, I reflected this experience. I spent a couple of days on it. And I thought, so what tooling can help me with it to next time to finish this investigation in hours and better probably even enable dev people to do it instead of DBAs. And the Oracle has very simple answer for this type of problems. It's the 146 signal. It's a tracing when you enable it on a certain level. So it writes everything in the file, every single syscall, every single tuple, the raw joint, everything, very detailed, like real tracing. And I decided to create the PG146 extension that will do it in Postgres. And the prototype was really good, so I'm really proud of it. But for wait events, Oracle also traced the wait events. And I did the same, but I had to sample it because I didn't find by that time any tracing approach for wait events in Postgres. I know when I start posting on LinkedIn this, Jeremy Schneider came and commented. So yeah, while it's really nice, you cannot call it 146 because wait events are not tracing. Very true, but there is no way in Postgres to do it.
Yeah. One second. I just wanted to send big hello if Jeremy Schneider listens to this, and I hope one day we will have him on this podcast. And Jeremy Schneider is important because he was like making it popular, blog posting about Ash a lot. And he was in the RDS team when they also started to do this, like performance insights and so on. So it's great that you connected over LinkedIn with him.
I think was also involved in the very good Wait event documentation that RDS and
oh yes, we
Aurora
discussed
have.
this with Dmitry offline a lot. Yeah.
Yes, I mean, it's really a lot of kudos to them for this work. Okay, and again, I was brainstorming with all LLMs that I had by that moment, and I start complaining. Sometimes I talk to them like to real people, and I was complaining. So yeah, I had a really nice extension, but lack of real tracing, it's a big caveat. And Claude said me, yeah, but you can trace. And I said, no way. How? And he explained me details how I can really trace the wait events. And for 2 days, I challenged this idea a lot for reason. It could not be me the first who found this. Not me, okay, the Claude found, but I'm not the first guy in the Postgres world who used this. Either this just does not work, or it was basically the only idea, so it just does not work because otherwise someone should find it before. Anyway, 2 days of testing this idea showed me that it basically works. And I started prototyping the tool. It's still in a very immature state, but it's already showing nice pictures and already can help to find some interesting, how to say, correlations. For example, I found that, that most of extensions now still use extension wait event. And when extension does something, you really cannot distinguish it from doing a real job or it's just a wait loop. When I use PGWait sampling, for example, to cross-check the numbers that I get from my tool and from PGWait sampling, I understood that the background of a PGWait sampling, just even it does nothing because it works in the background and there is no job for me. It's still in a waiting state, kinda. And so I think since PG17, you can have custom wait events for extension. And I really hope if someone listen, just please use the custom wait events in your extensions, that it will really help to understand, is your extension busy with doing some valuable work or is just spinning a loop?
Right. This is why in my PG Ash, also listening to Dmitry, I also spend some time analyzing colors. So green is what's usually called CPU. And this is why in PGH and in our monitoring tool, CPU has an asterisk. So CPU star means that it's CPU or maybe not. And we also discussed it a few times on our podcast. And yeah, so this is exactly why. So some extensions doing something, yeah.
I was just thinking whether PG Ash would show up in PG Ash with its own custom wait events, but then I remembered it's not an extension, so it can't.
Exactly. Fully
Sorry.
Postgres, through Postgres.
Yeah.
So that's basically the story how this came to life. So wanna me show it?
We cannot show it on podcast, unfortunately.
Oh, okay.
But just to recap, like you complained to LLM that something is impossible, and LLM said, "Let's do it."
Yeah.
And this is how it was
basically
born. This is crazy. So, it's like it means that it's good to sometimes complain. It would be good to have, unfortunately we cannot, and then maybe you just don't know how, and it's possible. It's great.
Yeah, brainstorm with the LLMs, I think it's one of the best features, yes.
Similarly, our monitoring, I remember I was talking to you and you said, oh, it's really hard or maybe impossible to show the beginning of query in query analysis in Grafana. And that's it.
You mean query text?
Yeah, we see chart, we see query IDs, but it would be good to see query itself. Is it select or something or insert? So I just went and did it with AI. And it's there right now. Because we had limiting belief like it's not possible. It's interesting. So yeah, AI helps here. Sometimes it doesn't help, but here it definitely helps to explore new options and create something new.
Yeah, and the new idea validation, that it's also one of fantastic features. You can really fast check the idea if it basically working or not. Of course, bring the mature software will take time. So, I mean, an LLM cannot do it in one night, but prototyping the idea cross-check. So that's, yes,
So
it's
this new tool
really good.
is tracing. So it's true, like it won't miss any wait event, or it still
Yes.
have some sampling. Or because when you showed me the pictures, which look amazing, I still think you need to post those pictures, to add those pictures to README, because this is like super impressive. And it was microsecond precision. I was like,
Yes.
my mind was blown. So it's really crazy. But then we started talking, and Dmitry actually came to our hacking sessions, which happen on Wednesdays online on YouTube. So a couple of times we sat and thought about how to do something, and that something was about changing Postgres, right? So why is it needed to change Postgres for this tool?
And here for this tool, we do not need to change Postgres. But the thing is, this tool has overhead.
Observer effect, right?
Yes, in more or less, I would say, if you can call it regular load, not pathological, let's call it an acceptable level, like 10%, something plus minus. So you pay overhead for every wait event transition. So when you get from one to one, and if you get more transitions per second, so you pay more overhead. And the maximum that I got was 220K transitions per second. And in this case, 220,000 transitions. Yeah, and so in this case, my overhead was basically 30% of the query duration. So not nice.
Was it with very tiny buffer pool, shared buffers, tiny shared buffers?
Yes, when it read, that's why it need to go to the OS to get the block, but block is in OS cache.
Right.
So that's why it's really fast.
And
But you need to, almost for every block, you need to go, yes. And even for evicting, so you need to pinning, unpinning, so all this kind of stuff. So it goes, I mean, in this case, I was able to generate this amount of transitions. And while it's a kind of a, how to say, not edge case, but kinda very synthetic. But anyway, so it says that the overhead, so I mean, you cannot avoid it. And when the Jeremy Schneider raised this concern about it's not tracing, he also said that so the patch for Postgres can be very simple. You just add two probes in these functions that used for set and unset wait events, and basically that's it.
And then
you created this
EBPF.
Yes.
Yeah.
And you created this patch for the.
I wanted to say that even if, like you said, for regular workload, it's not 30, like 10% overhead observer effect, it still sounds super useful to me to use it in lab environment. So if we reproduce some problem and study it, not in production, but on some clone or something, right? It's like I'm ready to pay 10%, 20%, and maybe even 30% because it gives me an exact understanding of everything what happened, right? But of course, it would be good to have a very low observer effect and have it in production right away.
To be honest, I personally would pay even 20% in production, just will instrument me to find the problem really fast. Because once I spent, I don't know, 2 or 3 days finding where the problem is because there was some changing in the security configuration of the server. And basically everything became very slow. And again, so I spent a lot writing custom tooling, custom scripts to find out and go to the problem. But if I had really good instrumentation, like we now discussing, so it would took a couple of hours to find the problem. And as the tunnel podder said in some of the comments, also, I mean, he was triggered by these pictures, that the observability is investment. It's not for free. And for example, in Oracle world, you just pay it, you just don't know it.
Right.
Because
No
I mean,
options.
you cannot have the Oracle that without the instrumenting. So I think they instrumented kernel in version 7.
And you cannot strip it out and test it without it. And Tunnel Podder is just worth mentioning, is a very like noticeable expert in the Oracle world. Yeah, it's great that also paths connected here. Yeah, well.
And that's why I think the wait event analysis should be in the capabilities for that should be in the Postgres core. And 2 ways of doing it. A small patch that you did with this
Did
probes.
some patch? I already forgot.
Yes. Yeah. But I wanted to go further and build the patch that will bring Oracle level of weight event analysis, bring this system time model, the tracing on the backend level. So without this, and at the beginning, I was skeptical and I thought that overhead would be kind of similar to this because why it should be really less. But in reality, it's way less. I have this patch in my GitHub. And so last couple of weeks, I was iterating it, making it better and better. And I hope it will be ready to propose to the community I know today. But today I was analyzing, there was a commit in the master that breaks a lot.
See, yeah.
Yes, they changed some memory management and basically it breaks some path in my code and I need to rework some.
Yeah, and it's like now it's the heavy work preparing Postgres 19, and it's maybe like slightly later it will be less like super active in terms of code changes, I guess. I wanted to mention not only one limiting belief was like, okay, it's not possible. Now you think, okay, observer effect is too high. And obviously it's not so high. And I remember the upgrade and post resume and PG bouncer, I had so big belief it won't work. But we see now how it works beautifully under huge loads and huge clusters. So just go and check, right? Now experimentation is cheap with AI. It's great to check instead of thinking it's not possible or hard. It's great. Like it's super inspiring to hear what you say.
Yeah, and back to the tooling, I still think it's very applicable in case I don't know if my patch or similar patch with a similar idea would be committed any day upstream, or you cannot afford new versions, so you will stick with some vanilla Postgres without these new capabilities. A nice thing that it's fully independent from Postgres. It runs like a sidecar, so you can switch on and off. You do not need to recompile Postgres. You don't need to change anything in Postgres. It just runs. You can start to next to it yes, you need to self-host Postgres. You need to have access to the box.
Root access.
Not root, but with elevated access rights for running eBPF, basically.
Okay.
And so that's a nice thing about the tracing. As soon as it's pure tracing, it's not sampling at any moment. It opens doors for very interesting things that are not even implemented in Oracle world. And here we can beat Oracle in Postgres because it's tracing. It means that we have a full history of transitions from one state to another state to the next state and so on. And you can reconstruct all performance problems or clashes or bursts in your system, not only in time, but also find the dependencies, who started the problem. Because even with a weight event analysis, with a sampling approach, for example, you cannot distinguish between you had 10 short IO weights or one long. With the tracing, you can do it. And you can find the session who started the problem. Because in a regular way, it's really hard to distinguish the session suffered from the problem or it caused the problem. So with this, I believe with the tracing, you can find the root of the problem and all the consequences of it. And with all these transitions, you can see it as the servers and can analyze this from the queuing theory perspective. You can get the already really mature mathematician approach and everything is already there. You can analyze it, how much you can serve in a given period of the time. And you can find the real bottleneck, for example, with a regular weight event analysis, you can see that a lot of IO, for example, IO is the bottleneck. But in reality, if you see from the tracing that by IO always gets the LV lock, for example, for any reason, even if you you would be able to solve the problem with IO, for example, find the faster disks. The IO would be shorter, but anyway, you would be locked by LV locks. So the bottleneck would be just moved to the next stage.
This is what makes benchmarking so hard.
Yes.
And what you're saying, as I hear, I don't know all the details, but what I hear is there is a mathematics like apparatus basically, which could help here and analyze bottlenecks much better and understand real bottleneck reliably. That sounds amazing. I want this. So
Yeah, so it's not at all.
Yeah.
So there's yet not yet, and I haven't more ideas. That's semi-implemented. So I'm just playing with it because collect data. It's not the even analyze the data. It's not the last step. The last step is present data to the human to make it consumable from human to understand this data to make the action. So this is the process analysis. There is again already people spend a lot of time, really smart people thinking, and they already have the really good approach how to analyze the graphs. And when you move data from one state, for example, tickets, when you move from one state ticket to the open, in progress, I don't know, test completed. And same with the, I don't know, the logistic, when you need to find the bottlenecks on your graph. And you can, with this math, you can find the patterns that the most frequent path is that, and the bottleneck is this specific state. It means that I don't know, most of your backends go through the buffer pin, for example. And buffer pin basically the limiting factor. And you do not need to even look at the dashboard with your eyes. System, not LLM, simple code can do it for you. We analyze the backends, traces. Yes, everything goes through the buffer pin, and so we analyze that the buffer pin and system can make 100K buffer pins a second, but your system demands 200. So basically you need to solve this problem here. So the problem is here. It's very deterministic approach. It can give the report really easy. You do not need hallucinations. You don't need to look at your dashboards for that. And so I think it opened doors for really interesting stuff. And one last, I think, idea that I have and try to implement already, system can find the deviations. For example, now for query ID, the common wait event profile is, I don't know, spend 1 millisecond in CPU, 1 millisecond in IO, and after that, sometime in the logs. But instead of 40 milliseconds, it took 50 milliseconds. And because it's introduced new wait event in between. So again, it's very easy to, I think, to write the code to make this analysis in a semi-automatic way. So you just can, like in Oracle, you open the 1 hour AWR report, but in the bottom you will have, so I made analysis for you. So the problem is here, the query with the query ID, change the wait event profile from that to that, and you have a problem with this, I don't know, disk or file or something like that. So it's a kind of a project, but I think it's doable nowadays.
Going back quickly, you mentioned, if we're self-managing using Postgres today, presumably this tool already would work for us. So I'm wondering what the changes in core would be that you want to make. What added benefit would that have? Or is it mostly about getting it to work on managed service providers or something else?
From one hand, this tool, I think, would enable a lot of DBAs to make the perfect wait event analysis. But moving these capabilities to the Postgres core will reduce the overhead from one hand. Second hand, that you will have it in vanilla everywhere. So you would not need to bring any tool. You would not need to have access to the box. You do not, because not all Postgres DBAs have it, right?
You have interface, or maybe SQL interface or something, or
So it's definitely going to be available through the SQL views. Yes.
But important question: we haven't started any discussions in hackers yet, right?
Yes.
So this is the interesting point. What will they say? Because
and why I still, want to make this patch, at least from the first look, really solid, because I expect a lot of pushback. Because it's a kind of a consensus for some reason. When I talk on any conf, on any place, to the production DBAs, everybody says, yes, we need it, no dubs. But when you talk to the people who has some weight in the community, who can really promote something, I would say they spend less with the real production issue, less time with the real production issues. And that's why probably they pushing back for any changes in core that can introduce the performance degradation, even if it brings a lot of new,
Value.
tooling for DBAs. Because it really depends on your perspective. I look at the Postgres as the production DBA. That's why I think I would pay 20% overhead. So I don't care. Just give me a tool. But
It's already so. It's already so. You don't need to go to them. It's this, as you said. It's already working with this like 10-20% or something overhead. Yeah, but
quick question on the tool as it is. It's on the GitHub repo. It says version 0.8 is the last one I saw. Are you working towards, what does 1.0 look like? What is it, reliability thing? Is it like a more tests thing? What's missing that you don't want to call it 1.0 yet?
Yes, I still, in some tests, it gets out of memory. So since there is a, leakage, so yes, I need the more tests, increase the quality of the code. And I want to get to run it on real box, not virtual machine from some cloud provider, on real box, to make, to say to people, so it's, if not production ready, but at least it's safe to run somewhere on the test environment. Because nowadays I still cannot say it for sure. But again, I thought I was really close to the patch to make this ready for community to start a conversation. I know it's a really long journey and I wanted to start this. And as soon as I had a feeling that I'm really close to it, I invested all my time last couple of weeks in the patch. And I didn't commit anything to this tool. That's, kind of a post, but I will get back to it for sure. But yes, the quality.
A couple of questions for those who are interested in trying out earlier. First of all, what are best use cases for it in its current state, not in future state? And second question is how to start quickly. Just clone repo and that's it.
I hope at least I tried to make the README up to date, and it should be sufficient just to go through the README to compile it and just run it. I tailored it for my use case, for my day-to-day life, and I hope that it's a good example and that people should be able to use it just after the cloning.
But I obviously see, for example, next big benchmark actually probably should worth using it to see how it helps to understand what's happening with that benchmark. But maybe what are the other cases, like some troubleshooting of complex situation in production and try to reproduce it on a clone or something else?
I think if you, for example, you have a problem, and fortunately enough, you can reproduce it, but you just don't know in some isolated environment. You just don't know what happens during the problem. You can run the tool and it would be just look into the problem with microscope. It will track everything. It will show everything to you. So I think at this moment, it's good enough for that type of usage, investigating of some problem in isolated environment. But if you're brave enough, you can try it on some close to some load in production, because you just can kill it.
Brave enough or desperate enough. Sometimes you have problem you cannot reproduce, and let's go to production if it's self-managed. In this case, someone goes and needs it in production because otherwise it's not possible to understand what's happening. Do you recommend to attach to only one backend or to analyze all of them? How's it better to use this tool?
I built it with the trace everything, including the auxiliary processes, these Postgres processes, because sometimes that's the problem. And I built this tool with this in mind. So just let's trace everything and have everything. So
but it's possible.
When you don't know, yes. It's default mode.
It's possible to narrow to only one session or only one backend. Is it possible? Yes. Possible as well, right?
Yes.
Good. So if it's just less risk is lower if you decide to analyze only one backend, right? Then
theoretically yes. It should be surface should be smaller, yes.
Right. Yeah, that's great. Yeah, I think I'm definitely will plan to use it in some next benchmarks I will be having. I had some benchmarks last Friday. I just realized I should involve this tool, but I'm going to revisit those benchmarks. They are fully scripted, so I guess I will just try and see what it will say. It's about this Q in Postgres tool. Yeah, I will definitely connect to you about that. So anyway, I'm excited to see this work. It's very unexpected for me angle of active session history analysis, which actually dissolves one of the biggest concerns about Ash methodology, which is sampling, right? PG statements are precise, unless query ID is evicted, or unless we talk about the part which is like cancelled statements, which statements don't see. But they are precise. It's just cumulative metrics, counters, incrementing, like tracking all. I really liked preregister statements when they were created, because before that we had only pre-PG Badger, we had PG Fomin, it's a French name, and it was PHP script, and it was based on sampling. Like everything is related to logging is painful, and sampling is painful. So okay, we now have exact, precise instrument tool to work with. But then Ash is impressive, great approach, but it's sampling based. Now you say Ash can be precise, and this is like new horizon opening for me. I'm super excited. Thank you for making this work. It's great.
And when I working on this tool and working on the patch for Postgres, I understood that there are some, how to say, gaps in the attributing time to the queries. That's not really, how to say, straightforward to understand. For example, the client read, the wait event that we see really often, but is it really database time or it's still client time? It's not that simple and easy, but even if you go deeper, so there are, for example, you ended the query, you open transaction, begin, you made some changes, the last update finished, and you issue commit or end. And really, you need to attribute the time and wait to end, to commit. I think it's default behavior. But also, even after commit, there are some work that Postgres does, some cleaning up. And from PG stat statements perspective, it's already not there. And some part of the work, it's a kind of unattributed. And it goes to nowhere. It's not really big amount of work, but still, playing with this precise tool will, if you're curious enough, so will get you to the next level of understanding how Postgres actually works, to the internals. Really interesting. I really like for that, because I never thought about it until I start working with it and playing with it.
Is it true that not only you can understand like exact sequence of wait events for this particular load, but also you can map it to source code, right?
Of course, nowadays LLM can explain it to you, so it's not a foreign language anymore, so you can speak to it. You can really easy to understand.
Which opens doors for more optimization of Postgres itself.
I hope so, yes.
Yeah. Like usually with GDB or with perf, now with this tool also it's possible. If you have some pathological workload, you reproduce it in synthetic environment. Let's go. That's it. Yeah, that's great. Michael, you wanted to add something, right?
Oh, only when you were talking about like unexplained overhead, it often shows up in explain analyze when you look at the difference between the execution time at the end of the query plan and the actual total time of the top level operation. You almost always see a small discrepancy there as well, and not accounted for anywhere, which is it's the same thing you're talking about, I think.
Yeah, a few percent there, and you lost $10. Yeah.
Yeah. Well, yeah, I'd like to echo what Nick's saying. It's really interesting work that you're doing, and thanks for sharing it. And also, I think you published the tool under the Postgres license, which is really cool. Nice one.
Great.
Yeah, I personally believe in it. So if you develop for Postgres, just share it.
Yeah. And what book on Q theory you are reading like for quite a long time, as I know?
Yeah, so it's a quite old one. So let me open
because it connects me to my current work, like this tool I just released, and I guess I need to read it as well.
I will send it. You can put it to the description.
Yeah.
Great. Okay, good luck with the tool. Definitely, I hope it will be popular, and I hope your patches will be welcomed in hackers mailing list.
Yeah, we will see how it goes. Yes.
Great. Thank you so much for
coming
again.
Thank you.
Thanks a lot.